Hello, Observability Con. It is an absolute pleasure to be here with you today. I'm Christopher, he, him pronouns, and today I'm going to be talking to you about how JustEatTakeaway.com load tests using Grafana Cloud K6. But first, a little bit about myself. I'm a senior site reliability engineer at JustEatTakeaway.com, and I've been here around 6.5 years now. I originally started out in one of our product engineering teams, but in this time, I've gradually shifted and found my home in platform engineering. I'm now based in the platform assurance team, and in this team, we provide reliability tooling to over 2,000 colleagues in our product and tech department. As you can tell by me being here today, I am very passionate about performance testing and ensuring overall system reliability. Outside of work, though, I do enjoy photography and video games, and yes, I do have a maxed Iron Man account on RuneScape. But if we have a bit of a look at the agenda for today, I'm going to give you an introduction to JustEatTakeaway.com, who we are, where we operate, and why reliability is critical for our business. I will talk to you about the importance of load testing and what can happen with the absence of load tests, what the risk to your platform is. This will lead us into how our platform has evolved over time and how we have adopted Grafana Cloud K6 and the benefits it has brought us. And then finally, I'll discuss how we load test at Jet, what we encourage our engineers to be doing. And then I will finish off with a couple of key takeaways for you. JustEatTakeaway.com is a leading global on-demand delivery company. We have over 350,000 partners, which are located across 17 different countries. These partners are then used by over 60 million active customers, and in 2024 alone, we took over 500 million orders. As I mentioned, we are in 17 countries, but within the countries, we are then split across another 15 different time zones. So throughout the day, we are processing thousands and thousands of orders. Uptime for us is key, and ensuring we can handle peak level load throughout the day, that is critical. And that is going to be a key focus of the talk today. So, load testing involves putting your applications and your services under different levels of load and monitoring their performance as you do so. So why is this important? That is one of the key questions I would like to try to answer for you today, and that I hope by the end of this session, if you're not already load testing, you have a strong desire and understanding of why it's important and the need to implement it within your organization. But first, I want to talk to you about application tiering at Jet. All of our components that get deployed into a production environment are given a tier. This ranges from a tier 1 component to a tier 3 component. Those that are tier 1 are those that are critical to our platform. These are required in order to process an order, or without these components, we would hold a legal or compliance risk. But on the other end of this scale, we have our tier 3 components. These give our users additional features. They improve our user experience. But without them, there is simply reduced user functionality, but we can still process orders. Our core business operations still work. We may see a minor conversion impact or a revenue impact, but the business functions. But what this really means is a tier 3 component should never, in any way, be able to impact the flows of a tier 1 or tier 2 component. So now, let me introduce you to our analytics service. This is a tier 3 application at JustEatTakeaway.com. And by definition, this means it is non-critical and should not affect our tier 1 or our tier 2 components. This service receives a lot of data. Per minute, it's getting over 750,000 requests. And at peak, even more so. But in 2024, this service went through a migration. It moved from legacy EC2 infrastructure over to EKS. And this is a migration we actively encourage teams to do. We have seen a lot of benefits containerizing our applications at Jet. But in this situation, it was done without any load tests being in place. To give you an understanding of the changes here, you can see our EKS and EC2 deployments. And in this, you can see how traffic is directed. For both of these, the traffic enters the platform the same way through the same API gateway. But on our EC2 deployment, this traffic goes to a dedicated application load balancer, which does what you would expect. It distributes the traffic between the various EC2 instances. Our EKS deployment, however, is a bit different. This deployment, the traffic again, goes into our API gateway, but it now goes to a secondary gateway, our Istio gateway inside of our EKS cluster. This gateway is not just responsible for our analytics service. It is responsible for application A, application B, all of those in this cluster. So for our analytics service, the traffic hits this gateway. It goes through the virtual service, to the service, and eventually to the pod. But that same flow happens for application A, B, and C, everything in that cluster. This migration, the analytics service did, it was not a big bang migration. It was done gradually over the course of a week. Each day, the rollout percentage was increased, and the platform and the service itself were monitored. So why am I talking to you about this? And like all good reliability stories, it happened to be a Friday night for us in the UK. People had finished work. They were ordering their takeaways. They were ordering their groceries so they could make dinner. And that's exactly what we saw happen. We saw our orders starting to come in. We saw traffic hitting our platform. The Istio gateway I just mentioned started our evening running at 3 pods. This gateway had a horizontal pod autoscaler configured, so it could scale out to a maximum of 5 pods. We started our evening at 60% capacity. This was not great, but it wasn't the end of the world. And then, as orders came in, so did analytics traffic. Users were interacting with our platform. They were going through our help pages, going through menus, and all of this generated more and more traffic. So to handle it, a 4th pod scaled in. Everything working as expected. We were at 80% of our HPA capacity. The evening continued. We got more orders, and we got more traffic. And we were now at 100% capacity. Unfortunately, at this time, one of the underlying nodes that these pods were scheduled on, it started struggling. It hit very high CPU usage. And that is when our entire evening completely changed. We saw a sudden drop in incoming orders to our platform. One of the 5 pods for our Istio gateway, it got taken out of service. This gateway, as I mentioned, did not just power or serve analytics traffic. It served traffic to other components in the cluster. And these components were our tier 1 and tier 2 components, critical to placing an order. I'd love to say things got better after this, but the evening continued, and we saw an even further decline in incoming orders. A second EKS node hit 100% CPU. These pods in the Istio gateway, they were split across 2 nodes, both of which were now struggling with very high CPU and very high memory utilization. We had 3 pods serving what at least 5, honestly, ideally a lot more than 5, were needed to serve. And it is very safe to say our platform was struggling at this point. So we engaged our on-call teams. We got our platform engineers involved, and we were able to scale out of this, and we were able to recover our platform for the evening. However, This incident had a drastic hit on our users and our business. Our users were hungry. They wanted to order their takeaways, their groceries, and every item they needed, and they were having issues doing so. But for our business, to this day, this is still one of our largest incidents we have ever encountered. So to summarize this for you, we are not load testing to celebrate every success. We're not testing to celebrate every green light we get from a test. No, we load test to uncover failures. And in this incident I just shared, it would have been prevented if it had been load tested before reaching 100% rollout. I want to make it very clear here though, I am not blaming the owning team for this. At justeattakeaway.com, we have a blame-free culture. And when this incident happened, Tier 3 services, they weren't often considered for load testing. It wasn't considered that a non-critical platform feature could have such wide impact on the rest of our platform that it could affect an upstream and downstream services. So from this incident, we had a lot of learnings, a lot of changes to how we architect our platform to prevent this happening, but also a lot of changes to how we performance test at justeattakeaway.com, which did lead to our eventual migration to Grafana Cloud K6. And I know you want to hear more about K6 and how we use it, but first, I want to talk about how we load test and how we have been at Jet. So let me introduce you to Rambo. At Jet, we have been load testing for many, many years, since 2016. We developed an in-house tool named Rambo, which consisted of a test orchestrator, a cache, and a cluster. This orchestrator brought up short-lived ECS tasks in our cluster. If these needed to communicate between one another, they had a Redis cache to do so. These tasks would then run a dedicated test engine, JMeter, Taurus, or Artillery. When Rambo was first created, it supported only JMeter. These other two engines, they got added to improve our user experience. And to further improve the experience, we added additional features. We, sometimes in response to platform incidents, had to add safeguards into Rambo. But because of all of this, Rambo became more and more bloated over time. So we wanted to have a look at replacements on the market. To do this, we wanted to take a user-centric approach. We did not just want to throw a tool out there to them. So our team provide load testing as a service to engineers. They write their own tests, and we maintain the service. So we did some user research. We wanted to understand everyone's needs and their current challenges with our tooling. Once we had all this information, we were able to build out some internal proof of concepts. We selected 2 services off the shelf. We set these up internally, which gave our team the understanding of how they work, what the maintenance was to maintain them. But then, more importantly, we could put these tools in the hands of our users. And that's exactly what we did. We gave our users some test scenarios and asked them, write a load test in service A and service B. And as they did this, we gathered feedback. We learned what they liked, disliked, and honestly, what they hated. But based on that, we could make an informed decision and decide on the service we wanted to use globally at Jet for load testing. Once we'd selected the tool, we wanted to deliver it. We don't just want to give them the service. We wanted to integrate it in our systems so it feels seamless to our users using it. And then on to the adoption phase. We wanted our users to get off of Rambo. We wanted them to adopt this new tooling. So after all of this, and as I'm sure you can tell by our talk title, we adopted K6 as our global load testing tool. In this process, we got a huge amount of positive feedback about the service. Our engineers absolutely loved it. But one very big thing about this, K6 was a tool picked by our engineers. It was not picked for them, and therefore they wanted to use it. They were excited to use it. So, how do we actually utilize this tooling? I know that's what you're all here for today. It's our global tooling used across all of our countries with engineers in for performance testing. And let's start off with pipeline testing. What you see here is a standard CI/CD pipeline. It's nothing new to you. The application gets built, and during that, additional steps are run. Unit tests, security scans, the standard. And it then gets deployed through QA, through staging, everything you'd expect. But we have added a new step for our engineers, a run K6 step. This does exactly what it says on the tin. It will run a selection of tests for our engineers, whatever they define. And based on this step, engineers will get immediate output. They will be told if their response times were within thresholds, were there any errors, and have any custom checks they defined, have they passed? If all of this comes back green, like in this example, the pipeline allows them to deploy to production, and they can do so knowing their performance has not been degraded. The customers are getting the best experience possible. But if this step had to come back with any errors, the pipeline could make a decision to prevent a production deployment, preventing any negative impact to our real users. This, for us, is critical. We want to shift left as much as possible, catch issues as early as possible. Alongside pipeline testing, we run a weekly analytics stress test. If you look back at that incident I just shared with you, this test covers that exact situation, and if you can see the metrics on there, it makes a lot of requests. In that 1 hour period, it made over 45 million requests to our analytics service, upwards of 17,500 requests per second. This runs on a schedule, so we can ensure the same issue we saw before does not happen again, and that any other changes teams have made have not affected our wider platform. But if the team that owns the analytics service needs to test it, if they've made a change, they can do exactly that. They have the ability to manually trigger a test. We also run order flow stress tests, and these tests are tier 1 applications. So those I mentioned earlier that are critical to our business function. And these tests run concurrently through all of the countries we operate in at once. And they cover that core flow. They go to our home page, the search page, menu, they build a basket, and they eventually place a test order on our platform. We do this to help validate changes that teams have made. Per week on the Just Eat platform, we make over 1,100 changes, and these have all been deployed through staging into production. We make a lot of change. So these tests help us. They confirm we can handle peak order traffic. However, all of these tests I've just shared with you, there is one additional thing about them. We do not only run these in staging. At justeattakeaway.com, we run all of our load tests in production environments. This is something we encourage our teams to do. We want production to be a part of their software development lifecycle. We want them to have faith in the components they are releasing, the components they are being on call for. And testing in production is how we achieve that. And I'll be honest, to a lot of people, this seems absolutely terrifying. Putting your production environment under peak level load when you also have real users using it at that time is scary. But that fear is what then gives you confidence You know that going into your weekend, yeah, you can handle it. The platform is good. So to summarize how we load test at justetakeaway.com, we offer pipeline testing for teams. They can embed this in their standard CI/CD pipelines and throughout their development process. This gives them confidence, and they can run these tests in staging, but also in production. Teams can run scheduled tests to get continuous feedback on how their applications are performing with change and with wider platform change. And then finally, teams can run on-demand tests. If they've made a change and need to validate performance, they can do exactly that, and they are empowered to run the test whenever they think best, in whatever environment is best for their situation. All of this we achieve using Grafana Cloud K6. And out of the box, we get a lot of very useful features. We get given curated dashboards with extensive test run information. All of the screenshots you've just seen, yep, got them out the box. But if you need to dig deeper into exactly how an individual request or endpoint is performed, you can do exactly that. We have thresholds, and when running a test in production, these are our number one feature. These are critical to us. If a test is experiencing any problems, thresholds can detect these, and they can stop the test automatically. So if we see an elevated number of 503s from a production test run, cool, they can be stopped automatically without any or with minimal user impact. Grafana Cloud K6 gives us 21 unique load zones. So this means we can test in a location relative to our real users. And if we need to test an internal service, cool, we can do exactly that. We can set up an internal load zone, and we can hit them endpoints. And then finally, out of the box, we get given a GitHub Actions integration. Within minutes of importing this to a GitHub Actions workflow, you can have tests running locally on the GitHub Actions runner. You can have them in your private load zone or running through Grafana K6 Cloud. And these are just some of the key features that we are utilizing every single day when we run load tests. So a couple of key takeaways for you today. No service runs in isolation. Load testing helps you uncover ripple effects across a variety of different services. As an engineer, you may believe your service will not impact any others, but just believing that is not enough. To gain that confidence, you need to have a test in place. You need to run a performance test and look both upstream and look downstream. Your tools should be there to serve your engineers. We had a user-centric approach in adopting K6. However, doing this resulted in a really fast adoption rate. With Rambo, we had teams, honestly, not wanting to write tests because it was a very tedious process. With K6, we had teams coming to us while we were still developing it and embedding it, asking us, can we be an early adopter? We want to write load tests. In platforms, this isn't something we see very often. So when you are selecting a tool, have your engineers select it, and they will want to use it. And finally, confidence lives in production. We all love our staging environments. They give us a lot of assurances pre-production. But the real test is how your production environment handles that traffic, how it handles intensive load. If there is one minor difference between staging and production, you could invalidate your whole test. Have confidence to run in production, and you will have confidence in your production platform. I do hope this has been really useful to all of you today. If you do have any questions, I believe we have time. Thank you.